And this is another edition of 3D Printing News Unpeeled, brought to you by 3dprint.com. So today we learn about a flexible architected soft robotic actuator for motorized extensional motion. This is a paper published on Wiley by Tae-Kyung Kim, Pranav Kartik, Ryan Truby. They're mostly from the Department of Material Science and other departments of School of Engineering of Northwestern. And they're working on soft robotics. And soft robotics, I've called it before, kind of like a science experiment looking for an application. It's one of those very promising areas where, well, nobody's really sure what to do with it. And the best way to explain soft robotics, if you're new to that, is instead of having a Roomba that has a lot of programming and software and cameras and chips and batteries and stuff to, let's say, vacuum your house, you would have like a little blob of TPU that would have static electricity. It would be statically charged, and it would roll around your living room more or less randomly as the sun heats your living room up. And then it would expand, and then that would cause it to roll around your entire living room and pick up dust as it goes away, along its way. So the idea would be you'd have a robot, but that robot would be a completely different robot than the one we're used to seeing. It would be, on the one hand, much simpler, right? Where a lot of the actuation or the movement or the intelligence, if you will, could be chemical or it could be mechanical. It would perhaps be much cheaper to make. It would definitely be kind of more easy to make that thing in one place than the entire supply chain upon supply chain that would be required to make a Roomba, which takes like thousands of factories across the world making, you know, the resin pellets, the molds, the wires, the chips, everything like that. It would just, you know, you could make a robot that would work very, very differently than your Roomba, but you could make it in one location perhaps. So it's always been a very exciting area, but at the same time kind of an area where like, yeah, but how would that work exactly? Or would that even work? Like some blob, some amorphous blob cleaning my living room. Would that even work? So it's always been difficult, but I like this very much, the next example, because it's a nice example, and they've been working on similar things for a long time. Essentially, one of the things that people have been working on is soft actuators. And that, of course, is really interesting because it would maybe lead to lots of different types of ways of creating motion or controlling motion in robots or other devices going forward. So it's like a building block for many other soft robotics applications. So what they've done now is make kind of like an artificial muscle / crawling robot. This is like something that will keep coming back in soft robotics. They love making crawling robots and kind of like, you know, kind of muscle type of stuff. So what they're doing is they have a cylindrical handed shearing auxetic structure. So essentially, auxetic structures are weird because they expand under tension. In this case, they've engineered it with a shaft and kind of an inner shaft and then an outer kind of cover, which means that it can extend using, in this case, a motor. And it can extend and close and also extend and move while being in a certain, held at a certain angle. So it's both extensible and bendable, and it can go in and out repeatedly. So what that means is that you've got like essentially a crawling robot or kind of a muscle type of structure. What they've done here is, well, I don't know what they've done here. It seems very powerful. It's a very interesting idea. And at the same time, yeah, what could we think of this thing? It could be a building block for more soft robotics robots, or it could be kind of like an advanced drain clogging robot or some kind of exploring robot that can go through really tight spaces. That's the thing here, and well, it's nice work, and hopefully it'll help some people at one point. Okay, the next thing is camera accessories. Now, this is a market where we've seen a lot of hobbyists on Thingiverse and other websites kind of make camera accessories. I have printed a bunch of camera accessories myself as well, and I really like using them. It's really useful to have that really specific accessory where perhaps there's no market for it because so few people want to use it, but some engineer or somebody tries to make everybody's life better by making it, and yeah, and others can profit from it. Now, this is another example, and the reason I bring it up is because it's for a professional camera, and I think this is an area where, so far we've got the open source kind of hobbyist, helping hobbyist kind of thing, there have been some things for some people who want to do lomography or kind of hobby type of stuff, but this is kind of really more aimed at the professional market. And I thought this was quite a trend we should spot, because that could be a huge potential source of income for a lot of people. Because imagine you're using a camera professionally a lot of time. That camera's really expensive. Every minute counts when you're shooting, especially if, like, I don't know, the light is about to go out or something like that, or the sun is about to go down, it's starting to rain, this kind of stuff. So every minute counts. You know, a production, any kind of professional video shoot where it's really simple, some guy doing a YouTube video, or it's like 20 people in a catering truck and stuff, it's really expensive. So if there's a small accessory, a small thing that might help them a little bit, well, they'll be willing to invest in it. So this is accessories for the popular kind of pro level camera called the Sony Burano. And what you can do is either purchase this accessory directly, and they have two accessories. They're both $15 or $25, so it seems reasonably priced. Quite simple 3D prints. They're basically covers for things, which 3D printing is really good at making, of course. And what you can also do at this point is download the digital file. So if you have a printer at home, you can just print these as you want to. So I like this model of a company saying, hey, here is the file, print it, or buy the thing for me directly. And I could see that maybe in the future you could sell the file for maybe $1 and then maybe sell the actual physical thing for $25, depending on where you were and what you wanted to do with it. So one is like the company's called Mid49, by the way. And they have like a flexible cover for the Burano's OLED panel. And then the other one is a loop plug, which is also a kind of a dust cover. So they're quite simple things. But I like this as a kind of like, imagine you made an aftermarket for everything. Like, so all the professional cameras, you had loop covers where there weren't any available or where they were too expensive. Imagine you had, professional, accessories for Hilti tools or Festool things or kind of other things that people used every day. And I think then certain things like a cover, which maybe could not be made anymore, would be super valuable. So I don't know. I like this as a trend. I hope this continues, because I think there could be real business here. And the next thing is 3D printing electronics. So 3D printing electronics is a nascent area. We may have seen millions of phones have antenna 3D printed, but we can't confirm that. It's definitely going on in sensors for government things, and it's definitely going on in some electronics applications where production runs of tens of thousands don't make sense with other technologies. Ultimately, of course, 3D printing electronics could be a completely new way of making your phone with a completely new form factor. But we don't know if that's going to happen, and we don't know when it's going to happen. And one of the things holding us back is accessible electronics 3D printers. There isn't like an Ultimaker or a Creality for the 3D printing or the electronics market. So you can't get like a Ultimaker level kind of, hey, good pro kind of thing. It's a couple of grand. You can definitely not get like a $200 thing that kind of semi-works if you just want to get started. And that's, of course, keeping a lot of research institutes and universities and people at home just getting started with 3D printing electronics. It's just not an accessible technology. There's also problems with slicers, and electronic software is less accessible. So there's a lot of stuff keeping back this part. And what keeps happening is people trying to sell accessible electronics 3D printers. Now, at one point, someone is going to succeed, and I don't know enough about this to know who will be, and maybe it's these guys. So there's Morningbird Space Corporation, which I think we can conclude is the best name ever. I think it's fantastic. And they've got an electronics 3D printer, the Electronic Alchemy eForge Series 3.1. It's a multi-tool, multi-material printer. It's a material extrusion system. It can take up to 6 materials, so 6 interchangeable tool heads. It's got a direct drive extrusion nozzle on there, so just regular material extrusion can be used for parts as well. And it's got a Titan arrow, a head on it. And it also comes with, and this is quite complete of them, with their own Electronic Alchemy Design Cauldron slicing software that can apparently, hopefully, handle these really complex tool paths and different depositions and stuff. It seems relatively attractively priced at $5,000, which could be very accessible for university and things like that. And I have no idea if it works or not. I just don't. But I'm just following this for you because, hey, one of these days someone is going to make something like this. It's not going to be in everyone's home, but for $5,000, if this thing would work and would be reliable, And then it would be a buy that literally very, very many universities, hundreds of universities would consider. So I don't know if it's this one. One day somebody's going to make a huge success out of this, and the sooner that happens, the sooner more and more people can start 3D printing electronics. Anyway, my name is Joris Peels. This was another edition of 3D Printing News on